So what I kind of want to do today is a little self-contained project. And it's going to be a kind of like a 2-button brawler style game. So if anyone ever played, I think it was called One Finger Death Punch. This is a game of the same kind of style as something that I'm going to try and produce. The idea is that you kind of have your character in the middle of the playfield. And then there are enemies kind of coming in from the side here. In this case, I think the way we're going to do it is to have enemies coming... Oh, something weird's going on with this. Okay. Let's have enemies coming from both directions. Ah! What's going on? So I'm using a tablet and it's acting really weirdly. Yeah, so enemies are kind of going to be like scrolling in from the side. And my thought is that if you use the left arrow key, then you're going to swing and kind of attack somebody. Okay, forget the tablet, that's not working for me. Back to the mouse. If you use the left arrow key, then you're going to attack to the left. If you use the right arrow key over here, you're just going to attack to the right. So it's kind of like almost like a rhythm timing game, right? As you have these big stream of enemies coming in from either side, and you have to kind of time your attacks, and maybe they have like a bit of a charge up or a cooldown to them, so you can't literally just spam left and right as quick as you like. Yeah, that's the kind of thing that we're gonna try and do today. So the tool I'm going to use to do this is called processing. It's the same thing we've used in the last couple of videos. If you're not familiar with processing, what it is basically is it's a tool, it's a framework or a tool based on top of Java. And the general principle is that it's supposed to make it really easy to get graphics drawn onto the screen. So loading in images, getting things drawn up there, playing with pixels, handling like keyboard and mouse input and stuff. It makes that super streamlined. So, you know, there's any number of frameworks and tools I could use to do this, but this is the one which kind of allows me to get up and running as quickly as possible. So I guess without further ado, let's kind of get started. So the first thing we need to do is to get our kind of background loaded in. So I'm using this background from our game, Steamhounds. So Steamhounds is a kind of turn-based tactical grid-based game. Kind of nothing like what we're producing today, but I'm going to be using some of the assets and sprites and stuff from it because, hey, we've got them there and I think they look pretty cool, so we may as well use them. So this is the background we're going to use. So I have already dropped this into our project folder. So I've created a folder here, and the way processing works is you have your main program, or they call it a sketch actually, and then you have a data folder in there where you put all of your assets which you want to load. So we have this background image. So step number 1 is going to be load this in and get this displayed on screen. So as usual in processing, the first thing to do is to implement this setup function. So processing calls this once at the start of the program, and it's where you kind of set up the window and the size of the screen and all of that sort of stuff. So this image is 1428 by 775, kind of a weird size, but that will do. So you literally just put the size in pixels there. You then also have to just specify a kind of mode that processing should run in. And P3D is just like the 3D accelerated mode, so it will take advantage of the graphics card and all that stuff, and it's kind of the more efficient ways to do things. We then want to load in the background image, so I'm going to create a variable for that. So I'm processing, these are called p-image variables. To load it, it's as simple as saying load image background.png, so it will automatically look in that data folder for us. The next thing to do is to implement a draw function. So this draw function is called every frame, so 60 or 100 times a second or whatever it is. And generally the first thing we want to do is clear the screen, or in this case kind of draw our background image in here. Where we draw the image is simply using the image function, then we specify the coordinates where we want to draw the image. So when you draw an image, so we have our window like this, right? And we want to draw an image into here. Our background image is actually going to fill the whole screen, so it kind of needs to be drawn right on top like that. And you basically give processing the coordinate of the top left corner of the image. And in processing, the top left corner of the window is coordinate 0, 0. Then it goes up to width over here. or height down here. So different tools may actually kind of start with 0 at the bottom and kind of Y going up like that, but you know, this is just kind of the way processing works. If you're using a different tool to do something like this, maybe you need to flip that around, but it should be simple enough. So if we draw this at 0, 0, this should be sort of anchored to the right place, and we should see our background. Cool. So there's our background image loaded in there. Looks good to me. Looks like the window and everything is the right size. Cool. So the next thing I think is to get our character loaded in. So the character we're going to use for our the player's character is this warrior character from Steamhounds. So I've already taken out some of the kind of sprite animations. So we have a little idle loop here. We have some other stuff we're probably going to use later. There's an animation of them getting hit, and there's another animation of them firing off an attack like that. What I'll probably do first of all, though, is actually just take out this first frame, and animation is something we'll deal with later. So I've kind of already organized this into a sprite sheet, but for now I think I will maybe create a new image with just the warrior here. Load that in pretty much exactly the same way. Oh, hey, Remain, thanks for tuning in. Yeah, if anyone has any comments or questions or anything like that, then you know, please do let me know. I'm always happy to chat with you all and kind of answer questions or go on tangents or, you know, whatever you want to kind of get into. Okay, so now we have our warrior. We want to draw our warrior character on top, and I kind of want them to sit. So the gameplay, right, is kind of going to happen in this plane here, right? This is going to be the floor level. You're going to sit in the middle, and the enemies are kind of going to scroll in from the left and right sides. So I'm going to kind of make note of this coordinate. So I'm using GIMP, by the way. If you're not used to this, it's kind of a free open source alternative to Photoshop. The coordinates of my mouse are down there, so I can read off that I'm at like well, I guess I'm half the width, right? So I can just actually use that in code to find the exact midway point left to right, but then from the top I'm about 650 pixels. So let's draw it at half the width, so kind of halfway across on the x-axis, and then 650, and see what this looks like. And I'm already anticipating this is kind of going to go wrong a little bit, but we can see what that is in a little minute. Yeah, so Armain, this is a tool called Processing. So this is the free and open source framework. The language it uses is actually Java. I'm using this because it's a very simple way to get up and running with graphics. You know, it's as simple as, you know, load image, draw image. There's no kind of library overhead and boilerplate stuff to deal with. But the point of this stream is not to talk about the specific language so much. It's more about the general principles and concepts, right? So if you're using Unity or Python or any other language or library or framework, like hopefully all of this stuff still applies and is more or less easy to transfer across. Okay, so this is not quite right? We've got our little tiny short warrior here. They're also, I said to put them at half the width and 650, which is supposed to be like here, but that's not quite worked. So there's a couple of reasons for that. The first is that I actually kind of mentioned before that whenever you draw an image, it is anchored to the top left. So we've actually put the top left of our warrior sprite at that point, and then, you know, the actual character's like down here somewhere. So what we're kind of going to need to account for is that where I really want to position the warrior is kind of based on her feet, right? So rather than based on 0, 0, there's actually kind of offset where I want to consider her position in the game, if you like, to be right here. I feel like that makes more sense. Hey, Blazing Fish, welcome back. Thanks for joining us again. So this position is about 60, well, again, I guess it's like half the width of this. So like 64 by like 122, something like that. So I'm actually just going to apply that as an offset. So this is kind of hard-coded for now, but you know, later on maybe we'll do this in a more intelligent way. I kind of just want to get it looking right for now. Okay, so our warrior is nicely positioned in the correct place there. She's still super small. There are ways I could get around this. What I kind of feel bad doing this. What I'm actually going to do is just scale up this image, like maybe to 300%. Again, Blazing Fish, you will remember, we take the shortcuts. If you can just scale up the image instead of doing it in code, then, you know, why not do that? One thing to be aware of, though, is when you're scaling up pixel art, you want to avoid it looking blurry. So by default, in most image editors, it will use some kind of interpolation, which is essentially smoothing, right? So if I scale this up, it looks horrible for pixel art. When you're scaling up pixel art, you want to not apply any kind of fancy smoothing. So I'll turn this to none. And then when we scale it up to 300%, we actually get what we kind of expect, which is each little pixel here being now like a 3x3 block. Yeah. So let's export this again. Now we have to reconsider the offset. It's actually like 187 by 367 for that point by the feet. Okay. Would I rather fight 100 duck-sized warriors than one warrior-sized duck? I mean, ducks can be kind of vicious. I don't know if you've ever had an encounter with a goose, like an aggressive goose. They can be pretty brutal, so I figure like a warrior-sized duck could be a threat. So I'd be wary of the duck. I would take on the tiny warriors, I think. I don't know. What do you all think? Okay, we've got our warrior kind of nicely positioned in place here. This kind of seems to work. Yeah, right. I feel like warrior-sized duck is the way to go here. Okay, let's get some enemies kind of coming onto the screen as well. So I have another sprite here, which is this enemy sprite. Again, they've got a little idle loop. They've got a frame of getting attacked, and then they've got this kind of swipe attacking animation as well. I kind of want to have them like slide in from the sides. Again, I'm just going to take an individual frame to start with, and we'll worry about animation further down the line. So I'm going to copy this into its own image, scale this way up, and then export. And then I'm also going to make note of where their feet are. So this is 95 by 152, give or take. Okay, right, I'm kind of drawing them right on top of the warrior. We will figure that out later. Okay, but we've at least got the scaling and everything. Right, wow, the warrior kind of looks giant. She's supposed to be kind of tall. She's supposed to be a pretty intimidating, kind of towering woman. So, kind of an aside, the concept for this character is based off of, you know, famous characters like, you know, Ripley from Aliens, or the knight from Game of Thrones, I forget her name. But, you know, big, imposing, kind of towering, kind of powerful women is the concept for this character. So that's why she's like 7 foot tall. Okay, let's start thinking about having this enemy positioned like somewhere else, right? So let's start him maybe... I'm thinking what would actually be kind of nice is if, you know, if this is our screen here, rather than thinking about our enemy's position, you know, like this is 0 and like this is half the width and this is the width. Since everything is based around this character in the center, it might actually make more sense if we consider this to be like the 0 point, and then this is like minus and this is positive. Right, I feel like that kind of makes more sense for what we're doing here. So let's say if their x is 100, in fact everyone's going to have the same y coordinate since it's all on this flat line, so I'm just going to create this as kind of a single variable here for that. So to figure out if this is supposed to be 100 from the center, then we kind of just apply it as an offset like this. Okay, so now our enemy is 100 pixels off to the side there. Let's actually try making them like way further away. Like all the way on the other side, perhaps. And then we can think about having them actually move closer. Yeah, thank you. I mean, partly it's because I'm kind of trying to explain things as I go along, but what I'll normally do is start by hard coding things, then pull them out into variables, then maybe pull them out into classes, then maybe reorganize them into like packages and systems and stuff. I like to get it working first in the most simple way possible. I like to, you know, run the code like often, and then to sort of iteratively do this, especially at this early stage of making a game. You just want to get stuff on screen and get stuff moving as quickly as possible. And also, the more you write before actually running the code, you always have these bugs, right? If you write like 50 lines of code or 100 lines of code and run it, almost inevitably something goes wrong. If there's a way to break it down into pieces, then generally I would prefer to do that. So what I'm going to do now is kind of move them towards the center every frame. So let's just move them by 1 for now and see how that looks. Whee. So that's kind of slow already. It'd be nice to have like a speed variable. And again, if there's something, if people have tuned into previous streams, you'll know that there's something we're not accounting for, which is that if my computer's faster and my frame rate is faster, then this enemy is effectively going to be moving faster because we're going to be drawing, you know, higher FPS, like more frames are drawn. So we're going to actually be moving the enemy more. So what I should actually be doing is keeping track of how much time has passed since we drew the last frame, and then I can kind of scale the speed by that elapsed time, so it, even if the frame rate changes, the actual speed things move across will kind of stay constant. So what I kind of want to do here is use a built-in function. Yeah, right. I can kind of just, I actually had to look something up because I couldn't remember exactly how in processing this worked. There's this function called millis, which does this, which just returns you an integer, I guess. Is that right? Yeah, which is the number of milliseconds since the program started. So what I want to do is keep track of the previous frame millis. So that's the number of milliseconds elapsed. Seconds elapsed, also, you know, often referred to as delta time. I'm just going to divide that by 1,000. And then I'm kind of going to remember that timestamp again, so that next time around I'll be able to work this out. So now instead of moving the enemy 1 pixel every frame, what I kind of want to do is have something like an enemy speed, which is now pixels per second. And since the enemy is off to the right, kind of moving towards the middle, I'm actually going to make this a negative number. Let's say 30 pixels per second. And now we can say enemy speed. There we go. Typically I'll do all the updating before I do the drawing, so I'm just going to move that up here. Okay, that's still kind of slow. I don't know, maybe that's not too slow, like gameplay wise, but I'll speed it up slightly for now. And actually I've changed my mind. I don't want this to be negative. I kind of want enemy speed to be like a constant. And then for each enemy I'm just kind of going to keep track of if it's moving left or right, kind of separately further down the line. So in this case we're going to subtract since it's moving left. Okay, our enemy is sliding in there, that's good. It's kind of bugging me that they're facing the wrong way around. They should actually be flipped. Probably I should leave this till later and focus on like the gameplay mechanics first, but it's so annoying to me that I'm actually gonna figure out how to make this work. Bring up the handy processing reference here. Now, we kind of got into some of this stuff before, but when you draw an image, I don't think it provides you a way to so it doesn't provide you a way to easily flip this, so we need to get into some transformy stuff. So generally speaking, what happens, especially in the days of like modern graphics cards, like when I'm drawing a character like a sprite, what I'm really drawing is like a quadrilateral, right? Like a polygon. And it really is actually 3D. It's just kind of everything's flat on to the camera, so it doesn't look like it. But what I can still do is like rotate this thing around as if it was a 3D object, you know, kind of this way. And if I rotate that 180, then it would effectively be the same thing as like flipping it left to right. So that's probably the way to do this. If I just do a normal rotate, it's almost certainly going to rotate, you know, in 2D, like, you know, rotate like that. So to do the flip, I probably need to use a 3D rotation function. So I imagine there's a function which takes 3 arguments for X, Y, and Z. Maybe not. Let's have a look at how do we rotate stuff. Oh, okay, so there's a handy rotate X, Y, and Z. So the question then is, which axis do we actually need to rotate this thing along? So generally, like, this is the x-axis is here. So if we were rotating it along the x-axis, we'd kind of be rotating it kind of like this, right? The y-axis is this one, so this is probably what we want because it will give us this like flipping around. If we did z, then that would be, you know, rotating it in that kind of sense, because the z-axis kind of goes into the screen. So imagine like putting a skewer through it and rotating it around that. That's kind of what that does, which is like standard kind of 2D rotations. So probably we want to rotate y. It probably expects an angle in radians. We can see this. Angle should be in radians, okay. I happen to know that 180 degrees in radians is pi radians. So let's see what this looks like. Okay, so as expected, something has not gone quite right, and that's probably because of the way that transformations work, where we actually need to do a bit more fancy stuff, whereby we kind of basically, once you start mixing up using this image function with certain coordinates and then rotation, it will tend to rotate it around like this 0, 0 point, so you know our character gets rotated around in space like this, which is almost certainly not what we want. Or in our case, since we rotated via the y-axis, we probably flipped them all the way over, like mirrored them over here somewhere, kind of along that axis. So the way around this is to use some of the translation functions. We just translate them by that amount, and then when we call the image function, we just specify 0, 0. This push matrix, pop matrix thing is basically like a sort of save and restore thing. So we don't want these rotations to affect other objects and things we draw, so we kind of save the state and then restore it. That's kind of what's actually going on there. Nice, okay, we have a character rotated. That is pretty good. While we're at it, we may as well think about rotating our main character here. So it's going to add a boolean for facing left, and then begin with that will be false, and then let's say whenever a key is pressed. Again, this is kind of like a magic function, like processing specifically looks for a function named key pressed, and it will call this for us whenever a key is pressed. We can use this to essentially like toggle facing left on and off whenever a key is pressed. And then let's do something similar with our Aria. And they're always going to be in the same position. So now we can just say if facing left, then we will do this rotation. Otherwise not, and then we can draw our character. Do we call them warrior image? Okay. See how this looks. Oh, okay, something is definitely not working quite right there. What is going on? Okay, this is... Okay, almost certainly it's because what we're doing is we're kind of flipping the image around around like this point, right? So that's what it's getting mirrored around instead of kind of the middle of her body, which is what we actually want. So there's a couple of ways around this. Probably the easiest way is to see if this works actually. So there's in processing there's two different ways to draw images. One is kind of anchored to the top left like we were talking about, which you do with image mode corner, and that's the default. But we can also use image mode center, which will kind of by default draw it around the center, and then we can probably stop bothering about this offset, which was this kind of distance from the edge to the midpoint there. It will also mean that that number we had for the y coordinate was wrong, because now they're centered around here, so we probably want to measure that distance again, so it's probably something like throw a guide on here. Yeah, so the distance from my legs to the middle is like 176. Oh, no. The same thing for our binary sprite. We're looking there at about 60. Okay, will this do what we want, or do we need to get more fancy? Nice, okay, we have our flip-flopping warrior, that's working nicely. We have our enemy moving in. It would be nice now to have some of the game logic factored in so that she can attack and the enemy will... Yeah, I mean, this is the kind of thing that you always end up fiddling with the first time you start a project, so it's probably something I've done dozens of times before, so you kind of just get used to it. The first time it comes around, it's super frustrating as you're just, you know, trying to figure out how to make this work through trial and error, but, you know. That's why it's also good to start on these little toy projects, because even though they're simple, small things, it really does set you up to have a much less frustrating time when you get into the real thing. So I think as we start to make this behavior a bit more complicated, I'm going to start probably factoring out some of this hard-coded stuff and loose variables sitting around into classes so that it's a bit more well compartmentalized. So I'm going to create a new class called player. And move all the player related stuff into here. And in setup, I'm actually going to create the character here instead. Then I'm going to move the drawing code. Also into here. This is not the cleanest code, like character Y is now essentially like a global up here. And I kind of want to call it floor Y because that's more kind of accurately in my mind what it is actually doing. But now I can just say, draw the player like that, and do something very similar with the enemy. Actually, you know, this is going to share a lot of code actually with the player, so it's beginning to make sense that maybe I actually have a kind of base class where a lot of this stuff goes. So I'm going to give these a position as well. X position is really kind of their only position, but hey. Okay, this is now something we need to account for because that's different between players and enemies. So this is kind of the offset from the center of the sprite to the position of the feet, because we need that to like align them properly with the floor. fact, we could even use constructors and do a lot of this stuff in here. I think it was 176 for the player. And for the enemy was 60. Okay, now we can pretty much just leave this here. Like when we get to do animation, we'll have to probably open this up again and do some more fancy stuff, but the enemy and the player now can more or less just worry about their kind of logic and behavior, and the actual like graphical stuff is more or less just bundled into this sprite class here. Draw the enemy. Another thing we need to do is actually create an enemy. The enemy has a bit more stuff going on. In this case, our enemy was facing left. Their exposition was over 2. Okay. So now we have this bit of logic for updating the enemy, which also needs to be pushed into that class. So what did we call this? What I'm going to do here is, I could be really verbose actually and just say if we're facing left, then we're going to move to the left. So essentially subtracting speed from our position. Otherwise, I'm going to move to the right like this. There are much more condensed ways of writing this, but it really doesn't gain us anything, so this should be just fine. This is really not the right place for this code, but again, it will do for now. So I give myself about a 50-50 chance that I did all of that refactoring without screwing anything up. Let's see. Cool. Okay, seems to be working. That probably means we could get a bit more fancy and have a list of enemies, for example. Rather than doing this, it probably kind of feels more convenient to put that into a constructor as constructor arguments. So let me do that here. So when we create an enemy, that stuff gets passed in, and then we just save it off kind of inside the object. If you're not used to Java, this is a weird quirk in that this variable that's passed in and this exposition, which is actually stored inside the object, are kind of separate variables. So this is how you kind of make it unambiguous. I want to store the exposition, which I was just given, into the exposition, variable inside this particular object. So that's the kind of syntax for that. Same for facing left. Now when we create the enemy, I can just say enemies, in fact. You can add an enemy, and they are facing left, and they're over on the right there. Oh, these are back to front, okay. I mean, we could be even more slightly fancy with this and say, you know, if the position is greater than 0, then that already implies that they're going to be facing left. If it's less than 0, it implies they're going to be facing right. So to remove the possibility of screwing that up, we could actually just have the enemy check that itself. So then we have this little Boolean expression, which will be true or false if, you know, it will be true if the x position is greater than 0, or false otherwise, which should kind of handle that for us. So we can just say where we want to put it, and then the left to right stuff will be automatically kind of calculated from that. Seems to make sense. Which means it's quite convenient now to add several more enemies. Maybe some on the left, maybe some on the right. So now when we update and draw it, we actually want to update and draw all the enemies at once. So we can use this for each style loop to go through all of those for us. For each enemy in the enemies, we're going to update and then draw them. Nice, we now have our enemies coming in towards us there. A slight issue is they go straight through us and nothing really happens. So maybe that's something we can look at next. So now we're kind of getting into the actual behavior and logic of things. Let's start thinking about how to approach this. I think what I'm going to go for... Okay, I'm going to try and use my tablet again. This did not work very well earlier, so I'm not holding up high hopes for this. The way I'm going to approach this is by means of something called a state machine, which is a way of thinking about... You know, it's very appropriate in this sort of situation where, you know, the player can be charging up an attack, or they can be on cooldown, or they can be attacking, and the enemies can be moving towards you, or they can be in like an attack state, or they can be in a state where they've just been hurt, for example. So each of the entities in the game are in one of these states at any given point in time, and at certain points, based on the user input or based on time passing or animation or something, they transition from one state to another. So this is a very common model. I'm going to start mapping this out for the player. So I think by default, if the player is just sitting there doing nothing, I'm going to say they're in an... Oh. Yeah. Ditch the tablet again. I'm going to say they're in an idle state. And then, gameplay-wise, the way I think I want this to work is that if the player, say, holds the right key, first of all, they're going to face to the right, and then they're going to start to charge up and attack. Maybe if they release the key before the attack's charged up, they just go back to their kind of idle pose. But once the attack's charged up, they can kind of hold that and then release it at a certain point to fire off an attack and damage or push back or destroy any enemies who are kind of within range there. So thinking about some of these states, we maybe have an idle state, we then maybe have like a charge up. So we're in an idle state, and then, you know, somebody's going to press a key. And they go into the charge state. And then the animation of, the pullback kind of thing is going to start to play. If they then release the key before that charge is finished, then they're actually going to go straight back to this idle state. So they release the key, and they can go straight back to the idle. But if they've charged up for long enough, then they're going to go, I'll call it like a ready state. And going from charge to ready is just a matter of time. Like some time passes. Try and draw a little clock here. If the animation's played long enough, then they kind of go into this ready state. And then when they release, I kind of want the actual attack to happen. So if they release, release the key, then they'll fire off the attack. And then again, just after a certain amount of time passes, after the attack animation finishes and kind of resets, then they will go straight back to the idle state. So this kind of covers everything that the player can do, more or less, right? This sort of state machine, by the way, is super common in things like fighting games, right? Where you have, abilities with charge ups and kind of, maybe at certain points they're invulnerable to attacks because they're blocking or they have invincible frames and stuff like that. So fighting games and for handling transitions between animations, this is like super common. So let's kind of get this going for the player. So a very handy way to represent states is using an enum. And all an enum is it's kind of creating your own type, which can only have certain values. And in this case, we know that that's idle, that's charge, that's ready, that's attack. Maybe we add on more. Maybe there's like cooldown phase or like a some other kind of phases in here, but for now that will probably do what we need. Okay, maybe it doesn't like it. Processing is not quite the same as normal Java. Maybe it doesn't like us putting that in here. So let's actually just say create a whole separate file for this. Probably won't complain then. And this is a variable. I can't just put any old random value in here, right? The only values I can put in here are members of the enum. Which generally will look like that. Cool. And then we kind of need to handle now the transitions between these things, right? So when we're in idle and somebody presses a key, then we're going to go into charge and ready and so on like that. So our main program is actually going to need to start passing some input along to this player, right? So this is where we get notified that somebody presses a key. And what I kind of want to do here is say, filter out the keys that we're interested in. So in this case, it's going to be the left or the right arrows, and then kind of inform the player class, hey, like the user's, pressed or released like one of these particular keys. So how do I check which key was pressed? This is another thing where different frameworks and libraries just have a slightly different but generally fairly similar way of doing this. So I think the way we do this is we say if key code. Let's see if there's a left arrow. Okay. Then we know the user pressed the left key. Else if they press the right key. We need to inform the player of something else. So I think what we'll do is we'll create some methods here which the main code can use to tell the player, hey, the key has been pressed. Just call it direction pressed. What I'm going to do then is indicate whether it's left or right just with a Boolean flag. So what do we do in a directions pressed? Well, it kind of depends what state we're in, right? If we're in the idle state, I would say what we want to do is we're going to start charging up, but we should also make sure that we're flipped and facing the right way. I don't want the player to be able to like flip back and face the other direction once they've started this whole charge ready attack thing. So I think what I'm going to do is say if and only if we're in the idle state. I'm going to do two things. I'm going to set our facing left variable to whatever key the player's pressed, and I'm going to then move into the charge up state like that. And just for good measure, I'm going to print something out to the console so we can see this happening. Since we don't have any animation and stuff going on right now, I'm going to do that. Or perhaps an even nicer way to do this is if, just like the enemy, we give the player an update function. What I'm going to do for now is I'm just going to print the current state out, so we always know what's happening inside the mind of the player here. Which should mean... Oh, I'm not actually calling this, am I? I keep adding code and not calling it. Let's also update the player here. Hey Xander, hey, thanks for the follow and welcome to the stream. So if you just caught us, what we're working on is a kind of 2-button brawler game. It's obviously not quite done right now. The idea is that our character is going to stand in the middle and these enemies are kind of going to slide in from either side. And by pressing the left and right arrows, I'm going to be firing off attacks left and right to kind of try and fend them off. That's the kind of real simple kind of gameplay, but that's what we're going to try and do. Right now we've just got these images loaded in. And we're talking about the kind of behavior of this player, like changing direction and charging up and firing off attacks and stuff. So right now we created this state machine where now they're in an idle state, but if I press, for example, the right arrow, then they transition into a charge up state. I mean, visually we can't see this right now. Yeah, then we're going to add something more from this. Right now they're kind of stuck in this charge state. You know, nothing else further happens, so we need to consider yeah, no, thank you, Fish. Yeah, so the state machine for this character is something like this. They start off idle, you press a key, an arrow key, and they'll flip to face that direction and they'll begin charging. If you release the key when they're still charging, then they go back to idle. Otherwise, if you hold charge for long enough, then they go into like a ready state and they're ready, the attack's charged up and they're kind of ready to fire it off as soon as you release, and then they go back to idle again. So let's basically just work on implementing the rest of this kind of flow here. So we know that a few things happen. If if the direction is released while they're charging, then we kind of want to go back to the idle state, right? So if we're still charging and they release the key, then just drop back to idle. Okay, seems simple enough. We need to actually tell the player that this has happened, so void key released. And then the code is more or less exactly the same here. Okay, will this work now? Let's have a look. So we're idle. I'm gonna press the left arrow now. So we see a flip over, go to the charge state. Then when I let go, we're back to idle, which means that we can start charging up an attack left and right again. Okay, this seems to be doing what we want. So what we now need to think about is, after a certain amount of time, we're done charging up, right? And we need to go into like a ready state. So what I think we need to know is how long should it take to charge up, right? So what I'm going to do is put a constant up here. This is kind of a standard way with these capitals to implement a constant. It doesn't change for different instances of this class. Let's just say it takes, I don't know, 1.5 seconds to charge up. Let's actually make this a constant as well. Kind of an aside, I don't really know why I'm doing this. It's kind of convention, but I'm already flouting convention pretty badly in this thing so far. Okay, so we know how long it takes to charge. We don't know how long we've been charging for. So as well as the state we're in, very often you find yourself keeping track of time in current state, right? So it starts off at 0. Then whenever we update, in fact I'm going to call it seconds in current state, that's more descriptive. Then just during the update, I'm just going to add on to this counter basically. But we need to be aware that when we change state here, we kind of need to reset that counter. So when we start charging, we want to reset the counter, because at this point, the counter will have however many seconds we've been idle for. But as we transition to charging up, we now need to kind of reset that. Similarly here. And you know what, let's actually print that out as well. And what we will hopefully see. Okay, we've been idle for a certain number of seconds. We start charging, time counts up. Okay, that seems to be working. Now we're at a situation where let's actually start marking off what we've done. So that's done. That's done as well. We now need to look at this. We're kind of halfway there, right? We've counted how long we've been in this state, but we now need to say, hey, when we cross that threshold of charge duration, let's automatically now transition into the ready state. So if we're charging and the time in the state is greater than or equal to the charge duration, that means, hey, we're in the charge state and we've just crossed that threshold. What we want to do is change to the ready state now. And once again, reset this timer. So there are loads, by the way, there are loads of ways to organize this kind of state machine, and they all have this similar pattern where you have state you're in currently. There are points where, when certain conditions are met, you transition from one state to another. Often there's some like time counting involved. And then very often in your kind of main update code, you'll do different stuff depending on what state you're in. So maybe I'll reorganize this to be a bit cleaner later, but for now, this more or less covers what we need. Which means that now. Okay, we're idle, we're charging, wait for a second and a half. Okay, now we're ready. Okay, we're stuck in the ready state forever, but you know, the next step is now making that happen, so that's done. Okay, what we want to do is say, if somebody releases the key when we're ready, then that's when we would actually do the attack. So, quite simple here actually, in a very similar way to this. We're in the ready state and the key is released, then actually now we want to switch over to an attack state in a very similar way. Cool. Let's go ahead and make the rest of this all work in one go. So when we release, we're going to go to the attack state, and then when we've been in the attack state for a certain amount of time, we want to loop back around to idle. So let's just throw that in here. So if we're in the attack state, then we presumably also want like an attack duration, which is probably going to depend on the animation, which we'll kind of get to a bit later. You know, maybe it's like half a second. Then we're going to go back to idle. Okay. So I think this will now give us everything we need to kind of transition through all of these back to idle and attack in each direction over and over again. So I'm going to press the right arrow key, charge up, let go. Okay, back to idle, charge up, let go, back to idle. If I hold it for long enough, switch over to ready. Now when I let go, we're attacking, and then back to idle again. So hopefully we can imagine if the animation was in place, then this would kind of do what we wanted. Yeah, so it'd be good to have some kind of indication. Maybe I'll throw this open to you. Should I work on getting the animations in for this, or should I work on making the attack actually do something to these enemies and start like dealing damage and stuff like that? And we'll try and get all of this done in the stream anyway, but yeah, what should I focus on? Like the animation side, or maybe just continue working on the gameplay and have this sprite kind of not really doing anything? Animation, okay, cool. So this is where things are going to get a bit more fancy. Okay, the enemy animation. Yeah, so there's something interesting about the enemy animation here. So I'm using this sprite from a the enemy state. Yeah, I mean, that's a good thing to work on, perhaps. I think that we can kind of work on the player and the enemy separately, to be honest. I mean, we can have the player attacking, even if there's nothing for them to attack and the enemies won't react, and get all that stuff hooked up, and then kind of work on the enemy, and then kind of bring them together in the middle and make them actually interact. But looking on the animation stuff, if I show you we have this kind of idle animation for the enemy right here. So because of the way Steamhounds actually works, what would be nice to have here is like, if I press play, it would be really nice to have an animation of the enemies like running towards you. But actually in Steamhounds, the characters never run. It's a tile-based game, and the characters are always like jumping from one tile to another. So I don't actually have an appropriate animation for that. So what it's going to end up looking like is probably the characters like doing their idle animation and just like sliding forwards along the floor. Like I probably can't do much better than that, to be honest. So that's what we've got to work with. So that's what I'm kind of want to use. But I'll show you how you actually get these animations loaded in and displaying. It will also be a nice way to show kind of visually what state we're in, I think. And let's start with the enemy, shall we? So what I have here already is a kind of sprite sheet for these characters. So the first row here is the idle, the kind of, rocking backwards and forwards animation here. I then have a frame for them being injured, and I have a set of frames for them like firing off an attack here. So I think what I'm going to do first is to think about loading in this idle animation. So in principle, what all sprite sheet animation is right now we have this single image, but instead of showing this single image, what we really want to do is first show this section, right, and then next frame move over to this section, and then this section, and then this section, and so on. So really all it is about is, for each animation we need to know what, how big the frames are, where they're positioned on this sprite sheet, how many frames make up the animation, how much time should pass between each frame being shown. So it's a case of doing like a flipbook style thing where we kind of show these bit by bit. I think what I'll do is start working on the sprite class to kind of handle this a bit more. So what I kind of want to do is create a class here to represent an animation. And think about the information we need to keep track of for each animation here. So I would say what we need to know is this is convenient for me because each animation is always on one row. So if I know like the top left coordinate, So Xander, to clarify, this is a sprite from a game, which is like a turn-based tactical game where there just happens to be no like running. The characters always like hop around from tile to tile, so we just don't happen to have like running animation for these particular characters. Like if you had another sprite sheet, then you could make that happen. It just so happens that we don't have that, so that's what we kind of have to work with now. Yeah, so what I think I need to know to make this animation work is what's the coordinate of this top left section, what's the width and height of each frame of animation, and then how many frames are there. I think that's pretty much what we need to know. So probably the top left X, the top left Y. The frame width, the frame height. Also, I think we'll need let's just do this in seconds. The duration of each frame in seconds. So I happen to know that these animations are spec'd out to be 50 milliseconds per frame, or 20 frames per... Is that right? Yeah, 20 frames per second. So now for each sprite, I think what would be nice to have is a kind of set of these bits of animation information. I kind of want to be able to look these up by name, so I'm going to use a map. If you're using another programming language, this might be called an associative array or a dictionary. It's basically like a lookup thing where I can say, give me an animation, I'm going to put something in there with a label of idle or attack and then pull them back out using those same names. Okay. So now our draw method is going to get a bit more complicated. What I want to look at now is if processing gives me the functionality to chop out pieces of an image, essentially. So Google time, I think. this is handy. So it looks like when you use this image function, it's actually possible to say, rather than drawing the whole image, okay, how do I pronounce your name? Keho. What bunny walks on two legs? I don't know. Enlighten us. What bunny walks on two legs? Bugs Bunny. Yeah, I suppose the world's most famous bunny. Should have got that one. Donald Duck. I think I know the pattern. Am I right? All ducks. Okay, I feel like you probably got most of us with that one. Fair enough, fair enough. Okay, so back to this sprite thing. What I kind of want to be able to do is to be able to draw a particular frame of an animation. This is going to be very similar. But I need to use an alternate version of this, which allows me to specify the exact fragment of the image I want to draw, right? So in this case, let's look up. So it's a version with 8 extra parameters, is that right? Okay, nice. Just gonna copy this out for my reference quickly. Okay, so these first parameters are the X and Y position where we draw that. So we've already handled that. DW, DH, I believe, are the width and height. So let's say we're trying to draw, I don't know, this frame here. So we have the width and the height. SX and SY are probably the start X and start Y, so they probably mean the top left corner of that particular frame. Okay, so you specify how big it should be on the screen, and then you specify which fragment of the image you're kind of pulling out. So, I believe what we're looking at here is something like, so we're going to take the sprite, we're going to draw it at 0, 0. It's going to be equal to the width and height of the frame. The start X is going to be, okay, let's start splitting this out, I think, to multiple lines for clarity maybe. So this is the position. It's the kind of target size like on the screen. This now is kind of going to be the top left. So we already know that. But if we're at certain frames into this, then if this is the top left of the animation, then if you're drawing this frame, we actually need to step across by 2 frame widths worth. So if this is frame 0, 1, and 2, then the start point here is 2 times the width of each frame there. Or And the top, since these are always on the same row, the top, like Y position is always the same. And the source size is also the same here. Kind of move these over a bit. Yeah, like 8 parameters, it's kind of crazy. It's easy to lose track of. This is where it's nice to have, there are some languages where you can kind of call parameters by name, right? So I could be like, I don't know, top left, you know, like with a colon or something. Java unfortunately doesn't do that, so sometimes you have no choice. Also, if you have a really nice IDE, it'll kind of like label these for you. Processing is very bare bones, so it doesn't actually do that, which is fine, but you know, in this situation it's not as clear as it might be. I never know like the nicest way to format this either. Like, should it be like this? Should it be more like this? And in that case, maybe I should pull them in like that. I don't know. I always debate with myself about the best way to format this kind of thing. So I've just done a whole load of stuff here. Let's check that this actually works for us. So I think what I'm going to do is I need to keep track of what the currently active animation is. And then it probably makes sense for me to actually have a change animation function here. And I can do something like pulling that out. And then in draw, I'm just going to draw the first frame of the current animation. So and since we're programmers, we like to start counting from 0, so it's actually frame number 0. Then what I'm going to need to do in here is to move away from using these single frame images and actually have these full-blown sprite sheet things going on. So let me first get rid of all this rubbish. Don't forget, I'm actually scaling these up. Yeah, these are super big, so this is really inefficient. If this tanks processing, I may need to do the scaling like in the game. If this works for now, then maybe we'll be okay, but I'm beginning to sense that this image is now like 13,000 pixels across. This may not be a good idea, but you know, let's see. Let's create a constructor for these, I think. Which just populates all these same things for us. Some copy and paste magic here. When I create an enemy, I'm going to add an animation. And we know that it has, what are we looking at? It starts at 0, 0. Frame width and height are 192. We also need a number of frames here. So this first animation was 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 frames long. And each frame was 50 milliseconds, or 50 over 1,000 seconds long. Okay. Let's also by default get that animation going to begin with. We'll do something very similar for the player. Except this dimensions are slightly different. It's 384 by 384. And how many frames is that? A lot. Okay, actually count it in here. 35. Wow. Okay. Okay, I've done a lot. This is almost certainly going to go very, very badly wrong. We'll have to do some cleanup, but let's see. Okay, there we go. Okay, I've probably named these files incorrectly. It's not Auria Sprite, it's Sprite Auria. And it's Sprite Enemy. Wow, okay, surprisingly this seems to have actually worked. Of course we're not actually animating now. What we now need to do is do a bit of... the sprite needs to handle some stuff in its update to do with progressing the animation frame along, that kind of thing. So... seconds since animation started, that makes sense. We want to reset that whenever the animation changes. We also now want to give this its own little update function so it can handle progressing the animation kind of over time. So there's a bit of logic that needs to go on here. So let's add on to the number of seconds elapsed. So now we know how long the animation's been going on for. We need to figure out which frame we actually need to display, right? So for example, if the animation was like 1 frame per second, and say there were 4 frames, this would be frame 0, 1, 2, 3. This is, actually let's say this is like half a second, 0.5 seconds for each of these. If we're, say, 1.7 seconds into this animation, then we know that that's half a second, that's 1 second, that's 1.5 seconds, So we're like somewhere interplaying this frame, so we should still be displaying frame 3 at this point in time. So we kind of just need to divide the amount of time that's passed by the duration of each frame, and then that would kind of tell us, if we ran that down, that would tell us what frame we should actually be displaying right now. So maybe we do that in here. So that is equal to seconds since the animation started, divided by the duration of that frame, and then we kind of just want to round that down to an integer. Although we also need to account for, if the animation's been playing for like several seconds and we're at this point, what do we need to do? There's kind of two cases, right? Like either we want the animation to loop, or we want to just stay on the last frame, and it kind of depends what type of animation we're talking about. So if it's like a idle animation, then almost certainly we want it to loop back around. Whereas if it's an attack animation, then hopefully our state machine will have moved us on to some other state, but realistically it's better that we hang around on the last frame with that attack than it is to just loop and start playing the attack again. That would be really weird. So I kind of want add another flag here saying whether this is looping or not. And then we can do something like, if the current animation loops, then we can wrap back around using modulus. Otherwise, we kind of just want to clamp it, right? So otherwise, if the current frame index is, on the last frame, or appears to have gone past the last frame, then we're just going to limit it to the last frame. And remember, if this is like a 4-frame animation, then the last frame is not 4, it's actually 3. So we need to do the number of frames minus 1. Now we can draw that frame index. Let's see what we've achieved here. Oh, so we also need to say whether this is looping. These are the animations we do want them to loop. We also want to make sure that in the update, we call this update animation method. I kind of want to do that at the end. The same for the enemy, make sure they update the animation as well. Ooh, craziness, craziness. Okay, get used to seeing this kind of stuff when you're playing around with like UV coordinates and sprite sheets and this kind of thing. Oh, what on earth is going on here? Okay, let's take a look. This is kind of trippy, right? This is I'm trying to figure out in my mind what's happening just by eyeballing it. What I should actually do is use a debugger and start stepping through this. It seems like for some reason as it's getting further into the animation, it's kind of drawing a wider strip of the thing. So let's see if we can just take a look and sort of eyeball this. It's almost certainly it's something here, right? Yeah. I think what's happening, so what we actually want it to do, right, is when we display the first frame, we want it to display like this section. Then when we display the next frame, we want it to display this section and then this section. I think what's happening is it's starting here and then it's displaying that, then it's displaying that, then it's displaying that, but it's scaling them back down to that same size, which is why they're kind of scrunching up like that. Yeah, so I think that's what's happening. So the main difference here is that rather than specifying the size of the section we want to chop out, we're actually specifying like the left and right and top and bottom coordinates. So I think then what we actually want is, that's the position. The target size is going to be as it was before. This is fine. That's correct. I might pull these out into variables actually to make it a bit more clearer. I don't know if this is terrible content or just like super realistic content. But believe me, in the professional world, I've spent many hours doing almost this exact thing with like different open source libraries and stuff like that. I really didn't want to get into like digging through the source code, but maybe that would have been more efficient. Gosh, okay, I really hope that I've cracked this now. So we're passing in the sprite, we're telling it where to draw it, we're putting in 0, 0 because we're actually using this to do the offset. Then we're specifying the size we want to draw it as, and then the top left of the frame we want to chop out, and then the bottom right, which is just taking that top left and adding on the width and height of a single frame there. Okay, fingers crossed. Whew, okay, something's happening. These look kind of funny, right? They're kind of cute, like shuffling along like that. They look like little bugs or grubs or something. Yeah, nice, right? I feel like I deserve a break, and maybe we all need to take 5. So this is maybe the point where first let me get rid of these numbers. There we go. Okay. Sweet. Okay, I think we're going to leave it for a few minutes now, and I'll be back in 5 or 10. Okay, catch you in a bit.